All right, let's go over your assignment, day 2 assignment. So here on this, whenever you had the bounds to your interval, that's the lower bound and the upper bound. And then you know that the p hat is the value right in the middle. So you could just average those. And so 0.40 was right in the middle. And then the margin of error is how much is from that 0.40 to one of the outside bounds. Now, then we come over here and you filled this in. So we put in our margin of error, our critical value for 90% confidence, and then we had our standard deviation, standard error of the statistic. So let's talk about how we get these numbers. And I also wanted to, I think I'm going to do a video separately on how to exactly do this with your calculator also. But so I won't even go through that on this. I'll show that to you on a separate little small video of how to go through this math. But when you leave everything in the calculator, because any bit of rounding can make a big difference. So it actually comes out to be 100.859996. So that means 100 cars is not enough. You actually, on these, always have to round up, even if it's a small amount, because you need to have enough to meet the criteria. So these we have to round up to be 90% confident and have a margin of error of 0.08. If you go down, then you won't meet that criteria. All right. Here, for a given sample size, higher confidence. So that means, we have to be thinking of what those components are to make your margin of error, the critical value, and then that standard deviation. Okay, and of course that standard deviation comes from this square root of p hat 1 minus p hat over n. Okay, all right, so this says for a given sample size, a higher confidence, so that means z goes up, means a smaller margin of error. No, z is going up, then you have a larger margin of error. B says for a specified, if z is staying the same, a larger sample, as n goes up, yes, it'll make the standard error smaller. C says for a fixed margin of error, so if we're going to leave this product the same, then if it says provides a larger sample, so if this n gets larger, then it is making this standard deviation smaller. And then, but it says for a fixed margin of error, so this product stays the same. So if this number gets smaller, then this number is allowed to get larger. So yes, Z's critical value has the freedom to get more confidence. Now, this says for a given confidence level, halving the margin of error. So that's this. If you do half the margin of error, then that actually comes from a 4 being on the inside of the square root, not a 2. So I actually wrote this probably the wrong way. Halving the margin of error, so half the margin of error is coming from there being a 4 on the inside of that standard deviation, because it comes out as 1 over the square root of 2. All right, here this was just basic. Can you make the interval? So I'm 95% confident that the true proportion of adults who say they believe in ghosts is between 35 and 41%. So now we're going to use this information and find the margin of error for this poll if we want to be 90% confident in our estimate. Okay, so 90% confident is going to change that critical value from 1.96 to 1.64. So this standard deviation stays the same, but that critical value will change. So that margin of error changes to that, decreasing that confidence level made that margin of error smaller. See, it was 0.0294, now it's 0.0246. All right, next, if we decreased the sample size from 1012 to 800, what happens? Well, then that is going to make the standard deviation larger, so that will make the margin of error larger. All right, here was another one where we were plugging in the values. Now this says we want to be 99% confident. That puts 1% split. So that's half of a percent. That's 0.005. So do you see how I had to do 0.005? And that is 2.33. Okay, so I'm double checking that one because I was thinking something else. So let's see here. Oh, I need to inverse norm that. All right, so then if that is the case, let me just double check that there. See, that is wrong. Inverse norm of that 0.005 is 2.58. So I'm going to have to fix this one. So I'll fix this answer and I'll put it correctly on your on this answer sheet whenever I do this. So I can tell that that's going to be a different number. So I'll change that. So look for that on the correct answer sheet. All right, in general, if all other aspects of the situation remain the same, the p-hat and the sample size, what will smaller margin of error involve greater or less confidence? So let's take a look at this. Here's your margin of error. If everything else stays the same, then a smaller margin of error is going to be less confidence because that's a smaller Z star. So the Z star gets smaller, then hence that lowers that confidence level. All right, so there's that. And again, I will fix this number on the answer key that I post online for you.